Hello students, welcome to Vector Physics classes. In the today's class, we'll discuss about the modern physics. It is one of the main branch of physics which deals with the post classical concepts of the physics. So the phenomenon explains with the help of two major ideas. They are relativity and quantum mechanics. The relativity is proposed by Einstein and we use the famous principle that is E equal to mc square. And in the quantum mechanics we use Planck's quantum theory, and according to that we use one of the another principle that is E equal to h nu, or that equal to hc by lambda. So in the modern physics is there some important chapters. So the modern physics is very important for all competitive examinations like JEE Mains, NEET and other competitive examinations after 12th class. Okay, right. So in the modern physics is there some important chapters. Look at the screen and there here the chapters. The first one is electromagnetic waves. Second chapter, photon theory. Second one is photon theory, and third one is matter waves. Fourth chapter, photoelectric effect. Fifth chapter, atoms, and the sixth chapter, X-rays. Seventh one, nuclei, and the last one, radioactivity. So totally 8 chapters are covered under the modern physics. Okay, right. So now one by one we'll discuss. So the first chapter in the modern physics is electromagnetic waves. So before we are going to discuss about electromagnetic waves, then first, what is a wave and how to classify the waves? So first we'll discuss about the waves. So wave means nothing but disturbance that created in the space and that propagates in the medium or space, and it transport energy and momentum from source to another place. Energy and momentum both. And the waves are classified based on some important parameters. So the first one is based on the requirement of medium for the propagation. So here the classification is taking based on different concepts. The first classification is based on the requirement of medium for the propagation, and the second classification is based on the transportation of energy, and the third one is matter waves. The concept of matter waves introduced by de Broglie, and there a separate chapter in the modern physics, and we'll discuss in detail about the matter waves later in the matter waves. Okay, right. The first classification of waves is this is based on the requirement of medium for the propagation. So according to this is there the waves are two types. One is mechanical waves, and the second one is non-mechanical waves. So what are the differences between mechanical waves and non-mechanical waves? For mechanical waves, they required medium. Means for the propagation, the mechanical waves required medium. Without medium, they do not travel in the medium. Best example for the mechanical waves, sound waves. So in the vacuum, the mechanical waves cannot travel because they required medium for the propagation. And the second one is non-mechanical waves. they do not require medium for the propagation. They do not require medium for the propagation. Means in vacuum also the non-mechanical waves can travel. Best example, electromagnetic waves for the non-mechanical waves. This is one of the first classification of waves. And the second classification is based on the transportation of energy. What is the main aim of wave? The wave is transporting energy and momentum from the source to another place. That's why through the waves we can transport energy and also momentum. That's why now here the second classification is according to based on the transportation of energy. So under this category the waves are two types again. One is progressive waves and the another one is standing waves. Now the progressive waves are transporting energy from source to another place. Here see, they transported energy. But in the standing waves, energy is redistributed. Energy redistributed. In the standing waves are also, they are called stationary waves. Standing waves or stationary waves. In the standing waves or stationary waves, energy is redistributed. And in the progressive waves, again there two types of waves. The progressive waves again classified into two types based on the vibrations of the particles of the medium. If the particles vibrating parallel to the propagation of the wave, then the waves are called longitudinal waves. Here in the longitudinal waves, the particles of the medium vibrates parallel to the propagation of the wave. Means in which direction the wave is traveling. In the same direction, means parallel to the propagation of the wave, the particles of the medium vibrating. They are called longitudinal waves. Again for this longitudinal waves, example sound waves. That's why the sound waves are mechanical waves and longitudinal waves. So mechanical longitudinal waves. Mechanical longitudinal waves. And in the transverse waves, the particles of the medium vibrating perpendicular to the propagation of the wave. The particles of the medium vibrating perpendicular to the propagation of the waves. They are called transverse waves. Electromagnetic waves or transverse waves. Electromagnetic waves or transverse waves. That's why the electromagnetic waves are non-mechanical and transverse waves. So this is a classification of the waves. So now it is very clear the electromagnetic waves. The electromagnetic waves EMW are non-mechanical transverse waves. Non-mechanical transverse waves. Right? Okay.